Today, only one human species walks the earth: Homo sapiens. We often think that this was always the natural outcome of evolution, but the truth is far more surprising. Tens of thousands of years ago, our planet was home to several different kinds of humans. They hunted, built tools, cared for their families, and adapted to harsh environments in ways that were often just as impressive as our own. So, why are we the only ones left? And what if history had taken a slightly different path? The answer begins in a remote cave, hidden in the Altai Mountains of southern Siberia. In 2008, archaeologists discovered a tiny fragment of a child's finger bone buried deep inside the cave. At first, it seemed like an ordinary fossil. But when scientists analyzed its DNA, they made an astonishing discovery. The bone did not belong to a modern human. It did not belong to a Neanderthal either. Instead, it came from an entirely unknown human group that had never been identified before. Scientists named them the Denisovans, after the cave where the bone was found. This discovery completely changed our understanding of human history. Most people imagine evolution as a straight line, from primitive ancestors to modern humans. But evolution did not work that way. Instead, it resembled a branching tree filled with different human species living at the same time. For much of prehistory, Homo sapiens were only one branch among many. Neanderthals dominated Europe and parts of Western Asia. Denisovans spread across large areas of Asia. On the Indonesian island of Flores lived Homo floresiensis, a small human species, standing only about 3.5 feet tall. In the Philippines, another species known as Homo luzonensis survived in isolation. Meanwhile, Homo erectus continued to exist in parts of Asia long after many scientists once believed they had disappeared. Each species represented a unique solution to the challenges of survival. The Neanderthals, for example, were perfectly adapted for life during the Ice Age. They had powerful bodies, broad chests, thick bones, and large noses that helped warm freezing air before it reached their lungs. Their strength was extraordinary. Many experts believe an average Neanderthal would have been significantly stronger than most modern humans. Their lives were dangerous. They hunted enormous animals such as mammoths, giant deer, and woolly rhinoceroses using simple spears. Unlike modern hunters, they often attacked their prey at extremely close range. The injuries found on Neanderthal skeletons reveal broken bones, damaged skulls, and other wounds similar to those suffered by modern rodeo riders. Their daily survival required incredible courage, yet Neanderthals were far more than powerful hunters. Archaeological evidence shows that they cared for injured members of their communities. One famous skeleton discovered in Shanidar Cave, Iraq, belonged to a man who had lost the use of one arm, suffered severe injuries, and likely had limited vision. Despite these challenges, he lived for many years. Someone fed him, someone protected him, someone helped him survive. That level of care suggests compassion, cooperation, and strong social bonds. Meanwhile, the Denisovans became masters of adaptation in a completely different environment. Evidence discovered on the Tibetan plateau revealed that Denisovans were living at extremely high altitudes more than 160,000 years ago. These regions contain far less oxygen than sea level, making survival difficult even for modern humans. Yet Denisovans thrived there. Over countless generations, they developed genetic traits that helped their bodies use oxygen more efficiently. What makes this story even more remarkable is that those traits never completely disappeared. When Homo sapiens eventually entered these regions, they encountered Denisovans. The two groups interbred, producing children who inherited genes from both populations. One of these inherited genes, known as EPAS1, helps the body function in low oxygen environments. Today, many Tibetan people carry this same genetic adaptation. In other words, a human group that vanished thousands of years ago still helps millions of people breathe more easily at high altitudes. And Denisovans are not the only ancient humans living on through our DNA. Most people outside Africa carry around 2% Neanderthal DNA. Populations in Papua New Guinea and parts of Southeast Asia possess even higher percentages of Denisovan ancestry. Scientists have also detected traces of mysterious human groups that have never been identified through fossils. Their existence is known only through fragments of ancient DNA hidden within modern genomes. These discoveries reveal something extraordinary. Ancient human species were not completely isolated from one another. They met, they interacted, they had families together. Their genetic stories became intertwined. This raises an important question. If Neanderthals were intelligent, adaptable, and physically powerful, why did they disappear while Homo sapiens survived? For many years, researchers assumed modern humans simply possessed superior intelligence. However, growing evidence suggests the answer may be more complicated. Neanderthals created sophisticated stone tools. They controlled fire. They organized hunts. They cared for their communities. They survived for hundreds of thousands of years in some of Earth's harshest environments. That does not look like failure. Instead, many scientists believe population size may have played a crucial role. As waves of Homo sapiens migrated out of Africa, their numbers gradually increased. Larger populations may have allowed them to share information more effectively, form wider social networks, and recover more easily from disasters. Small advantages accumulated over generations. Perhaps one group found food slightly more efficiently. Perhaps another group raised more surviving children. Perhaps climate changes favored one population over another. Over thousands of years, tiny differences became enormous consequences. By around 40,000 years ago, Neanderthals had disappeared. But their extinction may not have been caused by a single war, catastrophe, or dramatic event. Instead, it may have been a slow process driven by competition for resources, changing climates, and shrinking populations. And that leads to a fascinating possibility. What if history had unfolded differently? What if climate conditions had favored Neanderthals? What if Denisovan populations had expanded more rapidly? What if Homo sapiens had faced greater challenges during their migrations? The world today might look completely different. Perhaps cities would be designed by descendants of Neanderthals. Perhaps the dominant human species would possess greater physical strength than modern humans. Perhaps mountain civilizations built by Denisovan descendants would stretch across the highest regions of Earth. In that alternate history, Homo sapiens might simply be another extinct branch of humanity remembered only through fossils and fragments of DNA. The most remarkable part of this story is that the so-called losers never completely vanished. Their genes survive. Their adaptations survive. Their legacy survives. Every time a Tibetan person breathes comfortably at extreme altitude, a Denisovan inheritance may be helping. Every time certain immune responses protect modern humans, ancient Neanderthal genes may be playing a role. The other human species did not disappear entirely into history. In a sense, they became part of us. Human evolution was never the story of a single species marching toward victory. It was the story of many different human groups struggling, adapting, competing, and sometimes cooperating. Today, we are the last surviving human species. But hidden within our DNA are echoes of those ancient relatives who once shared this world with us. And perhaps that is the greatest reminder of all. Humanity's story was never just about us.